What's up, Algebra 2? 4.7, graphing in vertex form. Okay, so we're bringing this up to the front of the chapter where we're focusing on graphing. And because of that, you're not going to necessarily know how to do the fancy stuff to get your normal equations into this form yet, but we're still going to work on graphing it from this form. All right, it's called vertex form because this form gives you the vertex. Y equals a times x minus h squared plus k. All right, so the a multiplier in the front is going to stretch it out or flip it. Okay, if it's negative, it's going to flip it upside down. Here's the tough part. Okay, it's the nice part, it's also the tough part. It's the nice part because it tells you where to start, right? It tells you the vertex. The tough part is that you got to remember the pattern. It's opposite if it's inside the parentheses with x, and it's the same on the outside of the parentheses. Okay, so the minus sign is automatically, it's already built in. So if you see x minus 3, it's really 3. 3 is the vertex. If you would see x plus 3, you're tempted to call it 3. It's actually the opposite. It would be negative 3. And we want to think about like this, just moving, shifting your normal y equals x squared graph. So if it's got a minus, it's going to slide to the right. And if it's got a plus, it's going to slide this graph to the left. A plus on the outside does what you think it should. It's going to move it up vertically, and a minus on the outside moves it down vertically. Okay, your vertex is at h comma k. The minus sign is built in. I mean, maybe you want to think of this as opposite of h, same as k. All right, a times x minus h squared plus k. Opposites for the inside, same on the outside. All right, seeing it in action is going to be a lot better than looking at the letters. Okay, so here we have x minus 2 squared minus 3. So my vertex is going to be opposite, comma, same. So my vertex is going to be at positive 2, comma, negative 3. See? Easy stuff. Easy stuff. All right, and we can make a table. Make a table and build our table around it. Okay, you can always do that. Let's go with 1, 0, 3, 4. All right, you can type this into your calculator and use the table there to help you graph it. Make sure we're careful with those parentheses. All right, parentheses, x minus 2, parentheses squared, minus 3. Make sure it looks pretty much exactly like that. Oops, my graph's not in the right spot. Remember what to do if your graph's not in the right window. Zoom standard. Zoom 6. All right, there it is. Yeah, vertex is at 2, negative 3. We can push trace and type in negative 2, enter. Not negative 2, Mr. Handke, positive 2. 2, enter. 2, comma, negative 3. There it is. All right, we can fill in our table by just going through 1, enter, 0, enter. All right, and fill those in. We can go second graph to get to our table and use that to fill in your table, or you can just use math, right, and put 0 in here. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 minus 3 is 1. All right, you can fill it in that way. Okay. And then we can graph it out there. So we got 2, negative 3. And then 1, negative 2. And 3, negative 2. 4, 1, and 0, 1. All right, so there's that. We have our y-intercept on there at 0, 1. That was nice. We could probably do our axis of symmetry for extra practice. X equals 2. Okay, we don't have those zeros on there from last lesson. We could get those. We'll have another problem later on where we're focusing on all that. Right now, the main emphasis here is just, can we graph from this form? Okay, so a -2 multiplier. All right, let's focus on getting our vertex. Opposite, so -3, comma, same, 7. -3, comma, 7, okay? You can make an XY table, 1, 2, 3, 4, 5. Let's put -3, comma, 7 in the middle. Sorry, guys. -3, comma, 7 in the middle of your XY table. And you could fill it in. Okay, probably wouldn't hurt to get 0 on there. All right. We have a -2 multiplier, okay? Let's try just doing the points from the graph. Let's back it up. Actually, let's go up to here. There was no A multiplier on this one. So here's my vertex. If I go out 1, 1 squared is 1. So I go up 1. Boom, there's those 2 dots. From the vertex, if I go out 2 spaces, 2 squared is 4, up 1, 2, 3, 4. There's those 2 dots. Okay, so we could do that again with this. -3, 1, 2, 3, 4, 5, 6, 7. All right, we have a -2 multiplier. All right, so let's see how that would work. -2 multiplier. So normally if I go out 1, 1 squared is 1. But we got to times -2. So 1 times -2 is -2. So if I go out 1, down 2. Okay, if I go out 2, 2 squared is 4. Normally we'd go up 4, but we have a -2 multiplier. So 4 times -2 would be -8. We're going to end up going down 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and there's our 5 points. All right, there's our graph. Okay, again, you could do any of those other ways to fill in your table, and you should still get the same stuff, whether you're doing it off the graph, off the table on your calculator, or just doing the math. We should get all those same things. Oh, we said we were going to get 0. Okay, let's see. Would it fit? 0 plus 3 is 3. 3 squared is 9. Times -2 is -18. Plus 7 is going to be -11. So we'd be like down right there. All right. Nice. Okay, onward. All right, now these next 2, let's get super detailed, okay? Because on the quiz, in the test, you're going to have to be super detailed on your graph, right? You're going to have at least 5 dots, the vertex and 2 on each side, plus the y-intercept, plus the zeros. And you know what? Let's add axis of symmetry here too. Well, we need that line. Axis of sym. Okay, so let's start us off. What do we got? 5, comma, -9. Opposite, comma, same. 5, comma, -9. Okay, let me put that down. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's the vertex. Okay. Y-intercept. All right, this was a bad problem. I didn't do this very well. Because the y-intercept in the original form was super nice, right? When it's ax squared plus bx plus c, it's super nice because it's just the last one. Okay, we have to actually put 0 in. It's 0, comma something. So this was a poor choice on Mr. Handke's part. 0 minus 5 is -5. -5 squared is 25. Times 3 is 75. Minus 9 is 66. So 0, comma 66. Okay, that's not going to fit on our graph. Sorry, that was a poor choice. Okay. zeros. All right, this is from last lesson. Okay, this is from last lesson, so let's make sure we have this typed in. 3 times parentheses, x minus 5, close parentheses, squared. Bump it back down. Okay, minus 9. Zoom 6. Okay, we can see it's going to cross twice, 1, 2, and it does not look like they're going to be very nice. So second trace, 0, left bound, right bound, where are we at? There we come. So here's about where it's at, so left bound, left, 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 enter. Right, 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 enter. Guess in the middle, 3.2679, let's call it 3.27, comma 0. And the other one, second trace, zeros. Scooch on over to the other side. All right, left bound, left, 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 enter. Back to it. Right bound, right, 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 enter. Guess in the middle, 6.73, comma 0. If you get something like this, 3.3, e, negative 12, that e just means times 10 to the negative 12th. So that's like 0.0, that'd be 11 zeros and then a 3. 0.00000000033. Okay? That's basically 0. So 6.73, comma 0. And our axis of symmetry, remember, is always x equals the x coordinate of your vertex. X equals 5. Okay? So, we've got that. We got 3.27, 1, 2, 3.27, and then 6.73, so that's 4, 5, 6, 7, 3. Okay, ballpark that. 0.66 is not helping us out. That was a poor choice. And we need at least 5 points, right? So if I go out 1, 1 squared is normally 1, but we got times 3, so up 3. 1, 2, 3. If I go out 2, 2 squared is normally 4. 4 times my multiplier 3 would be up 12. So let's go up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I'm going to have more than 5 points this time. I'm going to have those 5 points plus the zeros. Okay, if you want to include your zeros as your 4th and 5th point and not do these top 2, that's fine. This is pretty steep, as we are expecting it to be. It's times 3. It's going to be a real steep parabola. Okay. So that's kind of the stuff you can expect on like a quiz or a test. Something like that, and you're going to have multiple things. We got our axis of symmetry on there too, Mr. Handke. Don't forget that. Okay. So something that detailed. Going to have your zeros, have your vertex, have at least 5 points with 2 points on each side, have the axis of symmetry. Ideally, we'd even have the y-intercept. It just didn't work out. Hopefully it works out better on the next one. Okay? Let's have you push pause and try to do all of that again. In fact, let's add axis of symmetry again. Let's have you go through and do all those real quick. All right. Push pause if you haven't pushed pause already. Welcome back. So we're going to have vertex of opposite, comma, same, -2, +3. Okay, opposite, comma, same, -2, +3. There's my vertex. Okay, y-intercept. Did I pick a better number this time? I think I did. It's 0, comma something. So 0 plus 2 is 2. 2 squared is 4. 4 times negative 1 is negative 4. Plus 3 is going to be negative 1. So 0, negative 1. 0, negative 1. That's a lot better. Zeros, we can get those in a minute. Axis of symmetry is always our x equals the x coordinate. So we can dot that in right now before we forget it. Okay, if you want to make a table for your other points, we can. We also need to make sure we get our zeros before we forget that. Okay, negative parentheses, x plus 2 parentheses squared plus 3. Okay, so there it is. All right. Second trace. We need our zeros. Let's start way over here. So here's where we think it is. Left bound, so click left a couple times. Left, 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 enter. I usually go 3 or 4, just to make sure you're obviously to the left or the right side of it. Right bound, right, 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 enter. Guess in the middle. Negative 3.73, comma 0. All right, second trace, zeros, all the way to the other side. Left, 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 enter. Right, 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 enter. Guess in the middle. Negative 0.27, comma 0. Okay, so let's get those on the graph. Negative 0.27, we're barely over there. And then negative 1, 2, 3, just inside of negative 4, we're right there. Let's get some more points on there. If I go out 1, 1 squared would normally be 1, up 1, but we're times negative. We got a negative multiplier in the front. We're going to flip us upside down, so we're going to go down 1. All right, so that would actually be, counting our zeros, that's already our 5 dots plus the 6th one there. If I go out 2, 2 squared is normally 4, but we're times negative 1, so down 4. 1, 2, 3, 4, our y-intercept, yep. And then on the other side, we'd be over 2, down 1, 2, 3, 4. Okay, if you want to keep going, you could. More dots equals a better curve. All right, but I think we're good for there. Ooh, I don't know if I've done a better parabola in a long time. That was a good one. That was a good one. All right. And again, if you don't like doing the dots, how I do them, you can always make your chart, make your XY table over here on the side, and you can get those off your calculator in a number of ways we've already talked about. Okay, last type of problem we're going to talk about is looking at a graph and coming up with the equation. All right, looking at the graph and coming up with the equation. So, number 1. Where's my vertex at? Negative 1, 2, 3, 4, 5, 6, 7, negative 7, negative 1, 2, 3. So my vertex is at negative 7, negative 3. Okay, so I can get a good start on this. Y equals A times opposite, so x plus 7 squared minus 3. All right, what's my A multiplier? Okay, let's come back over here. All right, we can use either of these other points on there and plug that in and solve for A if you want to do that. Right, I could put in negative 6, negative 1, put negative 6 in for x, negative 1 in for y, and do all this and solve for A, or I'm telling you there's a much better way. Use your pattern. Normally, if I'm here and I go out 1, 1 squared would be up 1. But how far up did I go? I went up 2, twice as much. Normally, if you go out 2, 2 squared is 4. Okay, but how much did I go up? 8, twice as much. Okay, so if I went up twice as much, what do you think my A value is? Times 2. Ta-da! All right. Now, I didn't give you the 1 over on this one. I didn't give you the nice 1 over. You got to think about this a little bit. I'll zoom in as much as I can here and still have it be clear. Okay. Let's have you push pause and give that one a go. All right, let's see how you did. So first off, 1, 2, 3, 1, 2, 3, 4, 5, 6. 3, 6. So we should be at y equals a times opposite x minus 3 squared plus 6. Now to find that a. All right, how far over are we here? We are over 1, 2. We're over 2. So 2 squared is normally 4. We expect to go up 4. But what did I really do from here? I went down, so it's going to be a negative multiplier. Down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I went down 12. Okay, if I go out 2, 2 squared is 4. I'm expecting to go up 4. But I went down 12. I thought I was going to go up 4, but I went down 12. What kind of multiplier would do that? Instead of going up 4, I went down 12. That's going to be negative 3. All right, and again, you could have started here, y equals a times x minus 3 squared plus 6, and then put in your other coordinate. Could have put in your other coordinate, either one of those two, and solved for a and got your a multiplier. Then just remember to come back and write your actual answer at the end. All right, guys. I think there's a worksheet. It's a homemade worksheet I just made that you can do instead of the book assignment. It's going to be more similar to these. So I would go ahead and do the worksheet instead of that. Thanks for watching, guys. Let me know if you have any questions.